morning, participants. So, welcome to the 46th session of day 6 of WADLA 3.0 on topic recent trends in deep learning and application. Today, we have with us Dr. Koustava Goswami from Adobe Research India. So, he is going to talk about multilingual representation learning in natural language processing. So, before starting his talk, so I would like to introduce him. So he is a research scientist at Adobe Research India. He has broadly interested in representation learning and natural language processing. More specifically, he is interested in developing deep learning algorithm for few sort, zero sort applications in multimodal and multilingual domain. During his PhD, he has focused on building different novel unsupervised deep model using representation learning, which can be applied to diverse low resource language and applications across language families. One of his work is to enhance the performance of the multilingual sentence embedding models for low resource domains in zero sort setting by injecting better word representation. His significant contribution during PhD include the invention of different unsupervised loss functions, including the maximum likelihood clustering loss function and the designing of a new machine learning framework called the anchor learning framework. He has also worked on instructional learning in structural learning using prompt engineering for few sort model training. During his PhD, he has also had intensive stints at different industrial research labs. His publication research papers appeared in various conferences, including AAAI, EMNLP, ICCV, Calling, EACL, EAKDD, WAC, IEEE, Frontier Journal, NA, NACL, ETC. So previously, he was a PhD candidate in the Insight Center for Data Analytics Lab at the University of Galway, guided by Dr. John Maker. So, welcome, Goswami, and you have come physically, so great appreciation for you. So, thank you. Now, the session is over to you.
You can hear me, right? Yeah. Or should I? Online people? I don't know. Yeah, okay, perfect. Good morning, everyone. So, my name is Koustava. That's a very broad, introduction. So sir has actually asked me for a bio. I have given this, and I didn't know that it will be written, so nicely every time. So, so my name is Koustava. I'm a research scientist at Adobe Research. I am working for India, but it's Adobe Research unit, which is in US and in India. So it's a whole unit that we are working. So. Here I am leading some of the works on multimodal learning, language models, instruction learning. Everybody knows about GPT response and others, but these are fancy terms. But so my PhD is mostly on multilingual learning and representation learning. I'm more interested in how do you understand and learn the representations that is there in the languages, in the space of image plus language, just language. Different languages in the whole world. It's more than 7,000 languages compared. So that's what I will be talking today. I know he has already said everything about me, but this is just a gist. So I have done my PhD under Dr. John Macker, University of Galway, Ireland. I just came back India last year, December, joined Adobe as research scientist. I'm a member of IEEE committee and XL member of Europe. I am a board member of the IEEE committee of Europe, where we talk about the different languages of anything. My research interests are mainly in multimodal, multilingual representation learning, large language model understanding and interpretability, which is very important because all these language modules are just black box sometimes. And one of the interesting things that we are doing here in Adobe Research is the hallucination understanding and the attribution based on the languages, images, and I have wonderful colleagues who are actually computer vision people. I'm not a computer vision people, but I work on this multimodal aspects. So I don't have an agenda where I will go through my papers. I don't like to do in that way. It's more of like I will be talking about what is there actually in the NLP of this multilingual, because I feel like multilingual NLP is still very underexplored. I have my senior Sebastian and others who are doing in Google. We are doing in Microsoft, but there is still a large opportunity to work on this. So it will be more of like interactive session. If you have any questions, just bombard me with the questions. I will be happy to take. So here is my agenda. It's more of like not an agenda, but just like how I'll just go through. Why multilingual and why it is very important to think about multilingual and just not text, but also in multimodality. And representation learning. We have to think that representation learning is not new. It's there for a long time. Whenever the statistical learning has been started, people have started fuzzy logic, people have started statistical machine learning, pure statistical people, those are also, representation learning. So I'll go through early years, human network data, the neural network data, the transformer era, large language model era, where people are saying that everybody can be done and they're willing to talk for the people. It's not true. And then multilingual, multimodal, and then I will come to some of the open research questions that we have, and I will be happy to discuss. I'll be here. So I'm here, so just come back to me if you are interested. So NLP is a vast topic, right? It's everywhere. Wherever you see, you can find NLP. People are now going to Amazon websites, Flipkart websites, any of these websites, and just typing their typing with the bots, thinking of, okay, I didn't get this. Can you refund my money? So those things are bots. How they are getting trained by the people who are doing the research in NLP. So NLP is a thing where you can find all these things can be done. Information extraction, machine translation, which is very important. Machine translation has actually helped us to cross the barrier of the region, culture. You can now go to Germany. When I was myself in Germany, I don't know German, sorry. I don't know German. I used to just translate it and talk to the people, interact with the people. So machine translation is very, very important thing. Sentiment analysis, which is everywhere. Like it's very easy to train, but nowadays sentiment has gone to the next level. And then you do this question answer, like all these bots. Bots are everywhere. So you do question answer, you dot these bots. But what is actually language? We have to understand this. The way I'm speaking now is a language. The way my mother tongue is Bengali. So whenever I am interacting with the people in my mother tongue, that is language. So every language has its own grammar, own representation, own way of saying, right? Like the people who speaks Kannada in Bangalore, who speaks Telugu here, I think. Every language is different. The way you are interacting with the people is the language. So it can be anything, right? So where is AI? AI has to understand and learn those languages in a way that we actually think of. Then only we can say that, okay, AI has reached the next level, which is still very far. And then, I have just given a snapshot of how many languages are there in the world. There are more than 7,000 languages which exist in the world. And I have just taken top 4 language families, which is, if you just see Niger Congo, this is a region in Africa. They have a way different languages, and their way of interacting is entirely different. They do in sign languages. Their way of thinking is more of like phonetics, like they whatever they are saying is more of like a sound. And then if you come down to us in the European, it's huge. In India, it's 26 official languages are there. So you go to my place, means third Bengal. Just go 500 kilometers from there. If you just reach Bihar, you will get Bihari, Bhojpuri. You go to Assam, you get Assamese. You come down to South India, you get everything: Kannada, Telugu, Malayalam. It's like huge, right? It's a whole lot of ocean where you can do everything with languages. Then if you go to Australia, people think that, okay, every Australian speaks English. No. There are 381 languages in just Australia. Australia is a huge part where you find people who are native Australians, they just speak on 381 languages. So understanding languages and working on the languages is very important. It's a very famous tree from one of my senior Sebastian, who is there in who is now in Google. When he was doing his PhD, he actually wrote down a very nice blog. It says that there are three kind of resources exist in NLP. One is high resource, one is low resource, one is medium resource. English is a high resource because it is very easy. All these models need training data set. So it is very easy to curate data set which are in English. Medium resources where you have more than one lakh or something, or I should say 1 million kind of instances to train a set. Even Hindi, I would say Hindi is now a medium resource because we get lot of resources in Hindi. In Bengali, I would say it's now medium resource because entire country Bangladesh speaks in Bengali, and we Bengali are there everywhere. So if you go to Telugu is now considered as sometimes, I would not go into the controversies, maybe medium or under resource. But if you come to the low resource languages, just like Delhi, where I used to stay, it's really the people where the getting data set of Delhi is hard, but you have to collect those data sets to train these models. Then only you can say that, okay, we have actually trained a model which can understand everything. But believe me, they are not still there. And NLP is overall, right? Whenever people are doing NLP, they do with machine learning, they do with just statistical machine learning, rule-based systems. When I was just capturing this picture, I was myself reading and thinking of, okay, I didn't know that people do NLP in such a vast way. Like you go and see that actually some people are just learning some of the rule-based systems in NLP for their company by just going to people, collecting the data set, talking to them, and making their system based on what they have actually discussed with the culture people from the multicultural. Some of the NGOs are actually going to the people, different parts of the world, collecting their understanding, bringing the whole system. So multilingual NLP is something which you can do by whatever you are doing. If you are a statistical person, you are very welcome to do a multilingual NLP because statistical thing is very important to understand where the data set is, how you integrate the data set, how then you feed down to the system that is there as a representational learning framework. What was there in early days? So when the statistical NLP was the thing before neural network came in, the rule-based system statistical NLP, how people used to understand the thing that has been written down in a document in a text format. Suppose this is the context. What they used to do, this is called bag of words, very simple thing. Bag of words is nothing but you will be generating the vocabulary of everything that you have seen in a document. Suppose you have this, and then you have all these 5, 10, 15, I don't know, 7 pages or something. Whatever has been written down here, they will be collecting as every part is your one token. That means every word is your one token. It can be article, it can be verbs, it can be nouns, everything. Then you just put down into the bags. It's nothing but a dictionary, right? Where you have everything as a vocabulary, tokens as a vocabulary, and then you represent that context using this bag. How? You take this context, and then what you will do, you will just collect how many times you have actually seen those tokens. And then you will make a rule. Okay, the rule is like if you are in English, the grammar of English is subject, verb, object. The way we will be saying the rules is like, okay, I have this many numbers which are the best, which has much more frequency than other numbers. Then this has to be learned in such a way that it should be very, very particular to this kind of context whenever it is coming. So I'll be writing down some statistical rules. If I give an example, you have a text reader, suppose small dog, cute cat, cute dog, something like this. Then what you will do, this I have said very overview. But when you will be doing your code, what you will do, you will take all the words which are not repeated, cat, dog, cute, small. Then what we'll do, okay, this is my sentence. Is cat is there? If not cat is there, I'll just put 0. If cute is not there, I'll just put 0. You will come to the second sentence, cute cat. That means there number the cat is cute is coming actually 2 times. So it is 2 times the cute is coming. So it's a 2 we will just put in the cute. And then what we will do, because that time the notion of word embedding was different. The notion of word embedding now is different. If I say in a way, this is actually the word embedding that time when the bag of words was there. Because people used to, computer cannot understand any of these words. It's just a binary system, right? Everybody I think has done BTech or is doing BTech. So we have studied that these are binary. Computer doesn't go beyond 0 and 1. Everything is 0, 0, 128-bit, memory bus, those kind of things. So how do you represent a word? You have to represent by some numbers. When bag of words was there, when statistical thing was there, they used to do using this frequency systems. TF-IDF, bag of how many times this word, what is the frequency of the word when it has been saved in the text. So this is called bag of words system. This is also a representation learning. In a way, you are learning the frequency of the words that or the tokens that is there in the particular context, and then you are making the bag. Then people actually have gone into the bag of words details and have actually generated systems based on that. I have just given a snapshot of a paper which has been written down, I think in 2006 by some of the people from Maryland. What they have done, that is a Chinese text. And you have a difference. This is the gold standard translation of English, of Chinese to English. They have 2 translations, translation 1, translation 2. If you see, the translation 1 is very bad. It's not at all near to what should be there as a translation to English from Chinese. But if you see the second one, it's almost there but not there. Because the way now they have trained it, by suppose they have collected long sets of Chinese documents, long sets of English documents. Then they have manually gone into a dictionary of Chinese English, which is their like handwritten Chinese English. And then they have done the manual alignment by doing the frequency, calculating the frequencies and others, and made this translation. So every time it cannot be perfect, but it did the job. But there are shortcomings. What are the shortcomings? You need the domain expertise to make this. If I cannot speak Chinese, so I cannot do this because I cannot go to the dictionary and see what is Chinese and English saying about this alignment. I cannot do that. You need linguistic expertise because you have to understand the grammar of the particular language. If you are not a native speaker of English, or if you are not trained in English, if I just give you a Chinese word dictionary also, it's impossible to do the translation in English by just seeing the these dictionaries and the roundings. Whatever information I give, it's impossible. Third one is, if you are a native speaker, then only you can do the perfect machine translation. Even this is not a perfect thing, but then you can say that, okay, I have actually 85%. People have actually done that. The earlier linguistic people who are the translators, they used to pay a very high numbers by all the services, Microsoft, Adobe, just because they were just hired to do the translations linguistically. They are called the linguistic statistical machine translators. So translators. So if you have translated just a one page, you used to your income used to be by words. Like if you have translated one word, it will be like 10 rupees or something. I don't know, but that is the way the machine translation was. But then something has happened, and I would say everything is mathematics. Everything is purely. If I give you a word in dictionary also, like a word to be translated into Bengali or Kannada can be having 3 words, right? Can be aligned to the 3 words. Now the highest probable word that has to be translated is the word that has to be aligned. So whoever is saying that, okay, I don't know mathematics, but I want to do representation learning, I don't think it is possible. If you have the language models, you can just say, okay, give me something. But that is not our research, right? So everything is mathematics, and that's how the probabilistic models have come into the picture into the second era of the machine translation. So if this is a very famous paper, a survey paper, or I think in 2006 it has come. Yeah, 2006. So the way that they have done is like, you see the equation here, right? You have P and S. What is P? P is the target. What is S? S is the source. So what is the probability of the target to be aligned to S? That is important to understand. And the probability which has the high, the target to S which has the highest probability will be the alignment. For an example, you have this sentence, the top part of the sentence, Spanish or something, Spanish. And the second one is the English. So there is a difference of writing down Spanish and there is a difference of writing down English. Suppose you take a German word you can see it's a long word. They just merge everything, what they say you will not understand. So an English sentence which has 5 words can be mapped to just a single word in German. Same as here, right? Who and light has been mapped to the second word, which is the source word. So how they do is like you have some tuples. What is this tuple? Null, V. This the second word which I can pronounce to the second 2 words, and vice versa. You will have all the tuples that are possible, and then what you will do? You will calculate the probability. If this is the highest probability, then you will take that. And how this happens is nothing but a conditional probability. That the first word, because this is a sentence, right? Every word of a sentence is actually related to the next part of the sentence. So if I'm writing down I am going to school is related to I am, because am is coming as a verb. Then to school should become because it is going to school. So every part or every token is actually dependent on the first part. Right? So that's how it was calculated, or it is calculated based on the conditional probability. Now these are called n-gram models. Why we are calling this n-gram models? Because these are n-grams. If you see, this is 1 gram. Then because this is 1 word. This is 2 gram because there are 2 words. This is 2 gram because there are 2 words. If I take 3, these are 3 grams. Diagram, we call it diagram. These are n-gram models. Is there any problem? Okay. Then IBM model has actually, but these models were very hard to do the alignment. Then IBM has actually come, early days, IBM research was fantastic, and their contribution to NLP is huge because they have come up with Watson. Now IBM has come up with some models. This is called alignment models. IBM model 1, IBM model 2, IBM model 3, model 4. I have just given a snapshot of IBM model 1 and 2, and I have taken it from a very nice researcher of India who is there in UNISAR, and I think he is related to Hyderabad, I think. So they have written down one paper or talk which is statistical model, and he's a great good friend of mine. So he's in UNISAR India now, in Bangalore. So what they have, so they have a very nice establishment as AI for Bharat in IIT Madras also, and luckily after coming back to India, because the multilingual group and others, I got connected to them. So Mitesh Kappa is running the. So coming back to the point, generative processes. Now these are also called generative processes or generation. This Gen AI. The quote-unquote Gen AI is not a new thing in anything. Because think in this way, if you are going to do any alignment or writing down any word based on the alignment or the probabilistic view, you are actually generating a word which has the highest probability. Right? When you are doing the alignment, that means you are actually generating that word. You are actually taking that word from that bag and putting down somewhere else. Just like in our childhood, we used to have that board game where you used to put that words. So you were actually generating, right? You were actually putting down those words. That is a generation. So this is a generative process one. There's a generative process one, generative process two. It's an algorithm where IBM model has said how can you actually do the alignment. So it's for each and every part, you actually select the best part that is possible. Now, these all are based on the system, like the probabilistic system. Everything is probabilistic, but this is very main probabilistic system. Now, when the neural network has come, it has changed the game. The way it has changed the game is fantastic. I'll first come to this one of the biggest thing that happened in NLP, which is when you clock, is the word embeddings, word embeddings. The way you actually understand the words now. Earlier, what I have said, like people used to understand the word by the frequencies, right? But now you understand the words by matrix, by vectors. That is called word embedding. So this is a simple perception. You have your inputs. Suppose I am going to school. These are the words. You put down through a perception model and predict what has to be, what should be the next word. I am going to, what should be the next word? School. If you predict that, that means you are actually training a classifier. It's a classifier. Training a classifier to understand what is the next word, to understand what is the main word. So it's a embedding space now, where each words which are very connected to each other will be very near to each other. Right? And the second one is called CBA. And the second one is skip drum. Why is skip drum? Whenever you are predicting the next word, you have to also predict all the labels. So if your word is now 2, then you have to predict I am going school. So that is the way you are actually predicting what is your neighbor, also what is your next words. This has changed the game in the world of NLP. So it's very essential to know this. I would not say just read this, but if reading this paper would be great. That if there are hundreds of blog posts and it is very easy to implement also. If you just write down the code by yourself, that will be great. Then every company has jumped in. First text was released by Meta AI, Meta Research. That time it was Facebook Research, now it is Meta Research. Is that one thing that was missing in CBAO or any this word embedding is like if the word is out of the context. Suppose it has learned 1 lakh words, but some word has come which is out of the box, which is out of the vocabulary. Then it will not be able to understand that word. So what first text has said, it is actually the understanding of the statistical and for a very long time. That is, you break a word into subwords and you calculate or you predict the subwords portion and then do the hidden steps. So this x1, x2, xn, these all are the n-gram features of words. So I am going to school. Think it as continuous n-grams. I, A, N, G. This kind of thing. Then you will actually understand what is the n-gram features, and then you actually predict what is the next word. That is how what will be happening. It's like you will be understanding. You will be actually solving the problem of the out of vocabulary problem. When you have a word which is a new word, you will not face the problem that okay something is missing. That is being solved by the first text. Next thing. The sequence to sequence model, and it has again changed the game. Earlier, it was based on the, I would say, the perceptron models and others. Then the sequence to sequence model has come. By the way, sequence to sequence model is not new. I think LSTM was given in 1997 by an Android paper, which has changed the world of the NLP. And how it has changed the world of the NLP? When I'm saying that I am going to school, all these are conditional probability. The way you actually learn the word embeddings is static. It doesn't have the information of what has been said earlier. Suppose you have taken I am going to school and putting down the word embeddings which has been already learned. You just extract it from a dictionary, as a matrix and put it down. But you don't understand what has been said earlier. So sequence understanding is important. So am, the word embedding of am should also consider the word embedding of I. Going should also consider word embedding of am and I. And at the end, school should understand the sequence of I am going to school. So the sequence to sequence model has actually changed the world of the NLP. And what is important is to understand the LSTM then the RNN, because RNN is the best, but the problem of RNN is whenever you are learning in this way, this is a very nice way of thinking. This is the first I, suppose this is I, then the next will be am, this is suppose am, this is suppose going to school, right? So, but what we have seen is there is something called vanishing gradient problem. This vanishing gradient problem is that you have a long sequence, and all these gradient-based systems are nothing but differential equations, right? So, when you are doing the differential equation, there might be the possibility that it goes to zero. That means you don't understand what has been said very early. And that's why the NLP community has actually taken the LSTM into account, because it has some gates, which is called input gate, output gate, forget gate. Don't think about this architecture, it's a complex architecture, but think about that it actually helps the model to understand what has to be the input, what can be just deleted if it is not needed. So forget gate does that thing. Remember that actually remembers what should be there as an input. And then many people have tried many things. Even I have tried many things on that. This LSTM was the thing, go-to thing for all the NLP researchers. If you are doing machine translation, if you are just learning sentiment analysis, people just used to put down a sentence to the LSTMs. And this LSTMs, by the way, if you see the way, because LSTM is the advanced version of RNN. So I have 15 minutes.
Yeah, you can.
Okay. So each and every hidden script has its own input understanding network. So whenever you are doing the machine translation, you can actually take those words embeddings, representations, and go to the next part saying that, okay, now I have to predict the next part. So using the LSTM, I have just given a snapshot of one of the paper. It's like what they have done. See, this is a long stack of just to do a classification. What you can do, it's very interesting that you can actually take some word embeddings and you can actually run LSTM on character embeddings. Because sometimes if you are just doing on word embeddings, sometimes what happens is like out of vocabulary things happens, and if someone has started from scratch, not has used the static embeddings of first text, then if you go to the character embeddings, then the understanding of those characters will be very, very essential. So you can actually put down characters to the LSTM as well to learn the subword level information. So you can do many things with this LSTM, and you actually learn the global representation using the LSTM. Because at the end of the day, what you are getting from the output is the global representation of the whole sentence or the whole character sequences that you have passed to the LSTM. But then there is a problem. If you are always going for a global information, then what about the local representation? Because every word is actually connected to the next word to do the machine translation, to do the classification. That's why the convolution neural network has been adapted in 2015 or 16, I think 16, by the NLP community. Convolution neural network is whoever is the vision researchers, they know convolution neural network in and out. So convolution neural network is very, very, very capable of understanding or learning the local representations. So that's why these are very successful in case of computer vision. Now, if you see this is the main part of the computer vision, right? You understand the next part of the image and how it is related to the first pixel, to the second pixel, third pixel, fourth pixel. Now think of it as a word box, just like this. When you have I am going to school and I am going to school. Now you are learning the condition between I and am as a local context as well, not just a global context. Because it has the convoluted, it is learning the convoluted parts of the sentences, and that is why learning the local representation sometimes is very important when you are doing the classification kind of tasks in NLP. And then the world again changed. The attention, not the attention already from Google, the attention in 2004 has been introduced. What this attention, and before that, the encoder decoder model has been introduced just for the generation. Now the actual generation happens. You have this encoder where you are putting down, suppose, a Spanish sentence, you want to do the translation to the English sentence. Your encoder takes the Spanish sentence, gives the representation of the whole Spanish sentence at the end. This is your representation of the whole Spanish sentence going to the LSP network. Pass it to the decoder, and decoder will generate each and every word for each and every timestamp of the English. That is called encoder and decoder model. Very simple. It generates every words at every timestamp. But what is the problem? The problem is when you are generating like this, you are not aligning or the words between them, which was important and which has been done by this IBM models, right? It was able to align between the words. That is where a famous paper has come, which has introduced the attention mechanism, where you actually, you have a context vector. With the context picture actually has the representation of the words of the encoder, and you have an alignment. It can be global or local, which is actually aligning the word of the decoder. So now you are actually aligning the way you used to align with the statistical models. You now actually aligning that back to the encoder decoder model. So this has changed the world, and this has changed the world. And then what we have thought of, okay, can we actually, people have done everything, but using this kind of local and global representations, can we actually understand the languages? If you have a document, have suppose 100 sentences in different languages, can we actually understand what these are actually saying? That is where we have built a system which is called a language identification system in 2020, I think, yeah, 2020. This was my paper in polling, where we actually says that you don't need any linguistic information to understand what is the language. If you have similar kind of languages, suppose you have Hindi, okay, suppose you have English, these are Latin scripts, right? Spanish, German, French, every languages are actually written down in Latin script. So there is a script. There is a way that you actually understand the scripts, and all these languages are actually coming from the history is same, and many words in English are actually taken from the Spanish, German. Those are called loan words. So if you can actually understand the information flowing between those words of the English and German and Spanish, even in Hindi, Bhojpuri, Assamese, this kind of thing, so these are coming from Sanskrit, then you can actually understand what is the representation of this language in a sentence, and you can actually identify what is the language. So this is a language identifier which can take any of the language from any of the language family. I think we have shown in 4 or 5 language families of 100 languages, and then you can actually understand what these languages are. And it is absolutely unsupervised that you don't need any annotation. So you're actually doing the clustering of the languages based on the sentences. And for that, we have this is the laws that time we have actually introduced, which is called maximum likelihood clustering laws, which is now in the Python library as well, where you actually understand how to do the clusters in an unsupervised way when you are actually learning the representations in a localized and globalized manner. And it is really important because you are actually learning the n-gram representations, nothing but the n-gram representations. And then the transform hierarchy in 2017. Transformer, the paper of attention, all you need actually came for machine translation. If the paper was mainly for machine translation, and it actually says that, okay, you don't need the LSTMs, just the transform block is sufficient. And I think everyone now knows the transformer block, but I will just give an overview. This is the transformer block. It looks like many things are there, but believe me, it is the thing which has many blocks. accumulating many mathematical things to be there, and it mathematically very nice to explain. The paper is very nice, very nicely has explained how can you actually do the mathematics behind this mathematics. And when the transform block actually came, the introduction of the mass language model has started becoming very popular. Before that, Elmo was there. Elmo was a language model. By the way, these large language models are nothing but you take any of the architecture. Suppose you take the encoder-decoder model of LSTM, you put down all the data set, train the model from scratch. That's how it is. Nothing more than that. Elmo was actually trained on an encoder-decoder model of LSTM. But then, when the transformer block was introduced, that's where the bombarding of this large language model has started to become, because it is very easy to use, it is very easy to adapt, and it is very easy to train these models now. I would not say easy to train, but it is not that difficult that you have to do those kind of engineering things, because transformer block is very nice of learning the features. And that's when the first large language model came from Google, which is the BART. And it has said that mass language modeling is now important. What is mass language modeling? You take the sentence and then you mask out 15% of it. And then you actually try to predict that words in a probabilistic manner. Nothing more than that in an encoder-decoder. If these are called encoder-based models, that means you encode the sentence. Decoder is nothing but it is just predicting those words, those masks. And it has changed the world. It was trained on a large crawl corpus, large crawl corpus. And then the bombarding of language models have started. MBERT, XLMR, XLM, PALM. Everybody knows about GPT now, because whoever does or do not do, they just say about, I know GPT. So these are the bombarding things of the language model that have started becoming. And these models are actually trained on the only, believe me, these languages are trained only on 100 languages. There are 7,000 languages in the world, but they can only think of 110 languages, because that's how hard to crawl a data set and train these large language models. These are some of the snapshots that I have given. This is an encoder-based model. This is BART. This is P5, which has came from Google, I think in 2020 or something. Colin has written down this paper. So BART, XLM, these models have said that okay, you have to predict the word. So it's a prediction model, mass language prediction model. But Colin has said during P5, okay, what we have seen already in a sequence-to-sequence models, that if you learn to generate something, that is better. Because learning of the generation is important to understand the sequence or the relation between the words. And that's how the T5 is. You give all the sentences in English, Spanish, whatever it is, it generates the next sentence. This is called a decoder-based system. That means you are generating that using the decoder. Then this is an XLM model, which actually has shown the first time in 2019 that you can train a multilingual model in such a way that it is called TLS method, translation language simulating method. That means you give this system, or suppose, see, this is an English word, and the next word is something Spanish, German, I don't know. So you take the English word, you mask out the Spanish word, give the language model to predict those masked out models of the Spanish, German, whatever it is. Then you are actually learning any language in the same vector space. Everything is coming in the same vector space, correlating. Then it's a bombarding of the papers happened. Believe me, these are the papers, even Indic BART is there as well. They have just taken the transformer model, any of the architecture, take your German language, Hindi language, whatever language, have trained the model and written down the paper. But how many standalone models you can build? It's not possible to build like German BART, Hindi BART, Tamil. It's not possible, right? So in 2021, so I have written a paper. It was published in EMNP, where I have given a framework which is called Anchor Learner Framework. What is this Anchor Learner Framework? So what is this Anchor Learner Framework? this anchor learner framework is important. So when you are learning a language model, these language models are good enough to have some of the semantic similarity of the other languages, because these are trained on huge languages. Why to train it from scratch? You take, suppose now I want to adapt it for, suppose, Bhojpuri, which was not a part earlier. You take a model, whatever model it is, because Hindi is very closely related to Bhojpuri. So there is a language model actually has the knowledge of Hindi. So if you see Bhojpuri now, Bhojpuri has a relation of Hindi. So you take a model, you take XLM as encoder, XLM as decoder. Sorry, XLM as encoder, XLM as learner. Now the encoder of the anchor is nothing but it is not learning anything. It is just a guider. It is doing nothing but just guiding it. What it is guiding, there are two loss functions, LA and LB. When you are doing the gradient understanding or the gradient learning, what you do is you have two language pairs, which is maybe Bhojpuri, Hindi, just pass it through it. What you do is, in the exponential 0 to 1 range, you want to push everything which is similar near to each other, which are dissimilar, you just want to push it out. And there is a concept called word over distance, which was very nice when you are learning how close two sentences are in a contextual manner. So what we have done is like we push the scalar value of the word over distance during the gradient calculation itself, and it is not a part of the subgraph of the gradient during the differential backpropagation, but it is more of a guide saying that okay, when you are doing the gradient learning, if you are bringing down two sentences which are apart, you are wrong, because it doesn't know anything about the language, right? Because this word over distance is there, word over distance is saying, hello, if I am bigger, that means your sentence contextually should be far enough. And at that time, the learning of the languages which are very far from each other will be very far from each other in the embedding space as well, because anchor is just guiding during the learning. And the learner is getting learned using an unsupervised learning. This is an unsupervised loss function. There is no label. And at the same time, you have LB. When you are doing this, there is a problem of translation ranking as well, right? Because if a translation of Hindi is not perfect translation of Bhojpuri, then you are learning the wrong thing. So what we are doing, we are handling that using LB, which is called a translation ranking problem. And then we are training this system as a multitask learning. One thing is LA, which is handling the part of the semantic similarity and putting down everything in the same equivalent space. And you have a LB, which is maximizing the cosine similarity between the translations and making sure that everything which are part of a language will be very similar in the equivalent space. And that's how it is, very simple. That's how it is. And actually people have now taken this model, and actually I was amazed to see that they have actually taken this model. They didn't do any multilinguality. They have just used this for a clinical, I think they call it clinical XLM or something. They have trained this using this anchor learner architecture. And they have shown that it is actually better than any clinical BART and others. They just trained it from BART, nothing more than that. They have adapted it to clinical domain now. But now everything is fine. But can you actually learn so one part of my PhD was this prompt learning and the instruction learning. So can you learn the instructions? If user is given an instruction, can you learn it? If you can learn it, all these GPTs and others, right? You give an instruction, you give a prompt. There is nothing, people call it prompt, but it is an instruction. In NLP community, it's called instruction. Then prompt came. So can you learn it? In 2020, so instructional learning in NLP is not new. It is actually old, because the way translators used to do, they used to build a template, rules. And then based on that rules, they used to instruct the system how to do the machine translation statistically. So instructional learning is not new. What is new is how to adapt these instructional learnings into the NLP large language models. In 2021, Liu has written a paper which became very famous. It is called p-tuning, prompt tuning. And then Colin has come up with, I think Colin only from Google, which is called prompt tuning. They said that okay, you don't give all these hard words, right? You just give word embedments, and let language model decide what should be that instruction for them to learn anything. So if you see, these all are nothing but some word embedments. There is no words. During the training process, or during the learning phase, language model decides, okay, what should be those words, because which will help me to understand. So that's how the instructional learning has gone to the soft prompt. This is called soft prompt. That means you are not giving him hard words. You're just giving some word embedments. And let language model decide what it wants. So in 2022, I think this paper has come in KCL, where they have said, okay, that is fine, but to adapt to some domain, I need some words. And that has been given as prompt. Is it from okay. So, but now what we have said, okay, that is fine, but how can we adapt the prompt? That is why we introduced switch prompt. This is a paper called switch prompt, which we introduced in 2023 NCL, where we say that okay, everything related to language model. Don't do anything. Just give soft prompt. Let language model decides what it wants. In terms of multilinguality, you just give some Spanish English thing, you just give some prompts, give some instruction, and let language model decides what it wants to adapt it. Suppose you are giving some Spanish English sentence and then you want to translate it. Give the switch, just plug the switch prompt and then just give the instruction. Switch prompt will take care of what it has to be there as an instruction, because it has some gates and it is able to understand what should be remembered, what should be deleted, what is important for the semantics level. This is called switch prompt. I just wanted to flash it because this is important when we are going to the GPT era, those kind of things. But then this instructional models, instructional based language models became very, very popular, and switch prompt has been adopted by the many, switch prompt now has been adopted by many people. Even some of the people who are doing the GPT based multilingual, they have adapted switch prompt just to make the switch prompt adapted to many domains. I have written this, but we will not, because of there is no time, we will not use the GPT as training, but you just go to GPT's thing, you just say that, okay, write down a poem in Tamil, and it is able to do that. Now, that is because it is able to learn that instruction that you have to do. So every language model is now instructional language model. I'll just take 5 minutes just to give some glimpse.
Till 10:15.
Oh, perfect, perfect. Thank you. So that is fine. Everything is fine. Everything is good. Everything looks fancy. Even GPT looks fancy. Everything is fancy. But these all are text. What about multimodal systems? Can you learn the images? Because images is something, as a human, if I see the image, I think of many things. I learn from the image also. So can you make multimodal multilingual systems? That is a crucial question to solve by any of the researchers like us. How do you solve that? Because as a human, if I'm going to some of the area of India where people know many things more than me, but might not be able to write down that much. But if you show a picture, they will be able to understand. So can you actually make multimodal multilingual systems? So researchers have now jumped into it. If you just search into the Google, a picture has its own words. A picture of grapes has its own words in Germany. A picture in grapes has its own word in English, in Hindi. So I would say every picture is multilingual, because it has something to the person from multicultural domain and has some wordings into it. So every picture is multilingual. There is nothing, I would say, unilingual for a picture. Everything is multilingual. So people have actually jumped in this multimodal multilingual, which we are doing in our lab as well. I have some interns this year also who are doing this. I have just given some of the snapshots of some of the work that people are doing. You can just go deep into this domain. I'll be happy to discuss. It's like you give English text, and then how do you learn it? This is called translation-based multimodal systems. You take an English system, you take an English words, English sentences, you translate it into Hindi, put it back to the image. This is called translation-based multimodal systems. Then the instructional multilingual blit has come, where they have the instructions in multiple languages. Where your multilingual language model is fixed. You give the instructions in different languages, you learn it for the picture, and you localize the part of the pictures. And that is important for doing this multilingual, multimodal things, right? Because every part of the picture says different things. And you have this, I have given some of the examples that some of the pictures of the multilingual instructions can be captured with any of the pictures. I'll just skip this. I'm almost done for my monologue. If you have any question, I'll be happy to help. These are the publications that we have done. I haven't put down some of the WebB and IEEE this year, but you can scroll through it. There are a lot of open research questions. Nothing is solved. GPT can solve some parts, but there are lots of research questions in this multilingual domain. First one is how to adapt to almost extinct languages in the world. There are languages which are now going to be extinct. Even I don't know how many people now say Sanskrit. So many researchers are actually working on Sanskrit languages, which is great. Second one is how to relate multilingual models to multicultural people. Adapting multilingual things to multicultural is important. That is a big research path to follow. Third one is, can you actually localize the part of the images for the multilingual understanding? Because if you have a picture, parts of the images actually says different things for a language. So can you do the localization? The fourth one is how to enhance better quality large-scale multilingual data sets, which is very, very important. There are lots of labs who are doing this, who are collecting the data set, but believe me, this is still an important research question to solve. So that's it from my side. I'll be happy to. So yeah, first of all, I will thank you for calling me and giving me this opportunity. I'll be talking to you after your talk, and thank you everyone for it.
Thank you very much, Koustava, for giving your wonderful talk. So now, yeah, participants, if you have any questions, so you may ask.
Yeah. So regarding this multi-lingual model, right? Say for example, if you want to have a say Bhojpuri converted, or you want to learn a particular language, how much amount of corpus is actually required? This is what do you think is about?
Yeah,
as you said, it's a low resource.
Yeah, that's a very good question actually, and that's why we have written this paper.
Correct.
So if you want to go for pre-training, then I would say a lot of data is required. But why do you need that? We have trained this system where you have only 2,000 data points for a language. I think one result we have shown on Manx. Manx is going to be extincted language from Gaelic society. And it has only, I think, 700 data points or 2,000 data points. But it was able to understand because Gaelic language, which is a closer language to the Manx, has the learning or the representations into the language model. And that's where the language model, the anchor, was transferring its knowledge of the Gaelic to the Manx. And that was very interesting. Even some recent paper in MNLP, so one of my paper in MNLP came for cognitive detection. Where we showed that if you don't know the cognate, or if you don't know, suppose you don't know about Bhojpuri cognates, right? But you know the Hindi cognates. You can actually transfer the knowledge of Hindi. And we have actually shown that 53 data points of cognitive science.
Okay, like you mean like Bhojpuri related to Hindi? Or
yes.
Like that?
Yes.
Because I want to see the ground truth now. When you need the actual translation, right? So one from Bhojpuri to either Hindi or Bhojpuri with English.
Bhojpuri to
Hindi.
Yeah.
So it means that you require that particular context conversion.
No, we don't need to require that.
You don't need.
Yeah. So here there is no parallel data.
No. Okay. So how do we know Bhojpuri? Okay. To be frank, how is Bhojpuri understood by computer?
Exactly. These models do not do not understand any grammar. This model just understands the representation.
So that's what.
So when you have actually trained the Hindi model, suppose you have taken the sentence piece, right, as a tokenizer. So you know the relations between the supports. When you are giving the Bhojpuri, because the grammar is same, you know the supports level information between the Bhojpuri and the Hindi. Because this is also a sentence piece tokenizer. What you are learning now is the semantic relationship. But you ask me, if you ask me that does this model know grammar? No, it doesn't understand grammar. We have some of the error analysis also has been done in this paper, where we have shown that if you actually try to go to Tamil from Hindi, it doesn't understand that because the grammar is different.
Okay, but let's say if we have when we have two ground truths, like for example, this is the exact translation of a Tamil, say Tamil with English. If we have what do you think? How much is required in that case? If we have a
That's a very good question. Yeah, for this we have some of the results of that as well.
okay,
There we have actually taken for Gaelic and Manx, we have actually taken 500 data points, 1000 data points. We have a graph, 500 data points, 1000 data points. We have actually seen that for 500 data points, if you have very good translation, it was able to understand because the translation was there.
yeah, that's what.
If you get 1000 data points, it is getting improved. It actually reached a point when there was a plateau. Is that after 1500 points, it was not able to understand much more because already the translation, what it has to understand, it has understood. The way this system was designed. But if you ask me, if you want to train it from scratch, just like XLM was trained from scratch, then you need a lot of data points for a particular translation model to perform good. Just like there is a model called Moses. That needs 50,000 data points at least to train a model from scratch. So it depends on how are you learning the representation. Are you learning from scratch or are you doing some of the mathematical representation? If you are learning some of the knowledge transfer of the languages, then less data points are sufficient. But if you are not transferring any of the knowledge, then you need much more data points.
Let's say we have English embedded. Let's say we take a book called the Rich Dad Poor Dad book. It's been translated to many different languages. From that, if I go, there is written. If I get the translation for that book, say for example from Tamil, I have the Rich Dad exact thing in English. Now, do you think it should be able to?
Yeah. So that is what it has. This XLM has done. So they have exactly did this. They have taken the Wikipedia, they have translated it to languages. Then they have this architecture where they mask out the source language, the target language, and then they predict. And they have shown that it actually performs. Exactly what you have to say.
So as we are running out of time, so we can take offline the questions. Okay, so once again, thank you very much.